Okay, so this video is on algebraic fractions. So this is kind of fractions plus. So this is for the higher tier papers. And they actually work in exactly the same way as you'd work with fractions, but so just normal ones like number ones. But the algebraic part means you have like x, y terms involved. So there are four common questions, like ways they can ask you algebraic fractions in the exam, so I'll write them down and then we'll go straight on to exam questions to look at like what you'll have for these. Okay, so these are the four different types of questions you get asked. So just like in normal number fractions, simplifying, so you've got the algebraic version of this. Same with multiplying and dividing algebraic fractions, adding and subtracting algebraic fractions, and then sometimes they have this weird ratio type question at the end. So let's have a look at some exam questions. Firstly, looking at section 1, simplifying. Okay, so this might be like this. So this is from an exam. Simplify x squared plus 5x over x squared plus 7x plus 10. So this is not just simplifying fraction, this is an algebraic fraction because we've got these x and x squared terms. So simplifying kind of means the same thing as factorising. Okay, so we're going to have to factorise and then hopefully cancel some stuff to like make it more simple. So first of all, let's factorise the top. So we need to pull out something that is common to x squared and 5x, and that is x is in both of those. So then what do I put in this bracket? So I'm going to put an x, because if I multiply x by x, I get x squared. And I've got x here, but I need 5x, so I need a 5 here. So if I expand that out, I get that back. So yeah, you can check that if you want. And on the bottom now I need to factorise this. Now this is a quadratic, so this is like factorising a quadratic. So we know we need to find, so the a here is 1, so we know we need to find a number that multiplies to give 10, and we also need to find a number that adds to give 7, the coefficient of the x. And then we know that because the coefficient of x squared is just 1, we can do this and put the numbers that work for this in here. So number that multiplies to give 10 is 2 and 5. So 2 times 5 is 10, and 2 add 5 is 7. So we've got plus 2 in here and plus 5 in there. Now that is looking promising because we're aiming to simplify, which kind of means make smaller. And we can see we've got two things common, one on the numerator, one on the denominator. So we can cancel the x plus 5, just like you would cancel normal fractions, and then you're left with x divided by x plus 2. So that's one example of simplifying an algebraic fraction, and it kind of just means factorise and cancel something at the end. So let's look at another one. Okay, so simplify 3x squared plus 9x, all divided by x squared minus 9. So this is an algebraic fraction because it's got the x and the x squared terms. So simplify kind of means factorise and hopefully cancel something. So if we factorise the top, we need to pull out something common in 3x squared and 9x. So we can take a 3 because that's in 3 and 9, and we can also take an x because that's in both terms. Now what goes in the brackets? We've got 3x squared and we've got 3x, so it's missing one of the x's, we put that there. And this 9x, we've got 3x, so we need to multiply it by 3. So if we expand this bracket out, we get that back, so we know we've done the correct thing. What about the bottom? So important thing to note here is this is something squared, well it's x squared, take away, so that's x squared, take away something squared. So it's x squared subtract something squared. So it's actually x squared subtract 3 squared, because 3 squared is 9. So this means we have the difference of 2 squared. When you have something squared, a square number, and you have to have this subtract is very important in the middle. So what you do for dots, the difference of 2 squares, is you put the x there and the x there, and you know it's 3 squared, so you do plus 3 in that one, minus 3 in that one. And yep, just like the previous example, which is what we're trying to do, you want us to cancel something on the numerator with the denominator, x plus 3 in that case, then you have 3x left on top and x minus 3 on bottom. So that's how you do that. So let's do another one. Okay, so we've got right 3x squared plus 11x minus 4 all over x squared plus 3x minus 4 in the form x plus b over x plus c, and this is a, b and c are integers, where these numbers in here are integers. So that's another fancy way that they can say simplify that into something that looks like that. Okay, so we know that this is a simplify thing, so we're making it look like that, which is smaller. So we know we have to factorize. So first I'm going to look at the top. So 3x squared plus 11x minus 4. So this is factorising a quadratic, but as we can see, the a term here is not 1. So it's kind of the harder version. So we need something that multiplies to give a times c. So 3 multiplied by minus 4, which is minus 12. And we need to add to give 11. Okay, so that number would be, so let's say we take 12 and minus 1. So 12 multiplied by minus 1 gives me minus 12, as I want, and 12 take away 1 gives me 11, which is what I want. So we know our numbers are these two. So the next step is you rewrite this, but you split up this 11x into these parts here. So I'm going to do minus 1x plus 12x. So it's basically rewriting the 11x in these terms that are split up. So I'm going to get rid of this to make some more room. Now we do the factorisation of each half. So we take out something common here, which is x. So we need a 3x there, and we need a minus 1 there, because if you expand that bracket, you should get that back. And on this side, we have 12x minus 4, so what is common? 4 is common in both. We need 12x, we need to multiply by 4 by 3 to get the 12, and add the x, and then minus 1. Quick check that these brackets are the same. Yes, they are. So then your final answer is these two brackets, one of which is the one that is the same, and the other one is the coefficient to the bracket, so the x from there, and the plus 4 from there. So we factorise the top bit, so I'm going to write that bit there, x plus 4, 3x minus 1, so that bit there, all divided by, and then we need, get rid of the equals now. Need this bottom bit factorised. This is like a normal one, so we need something that times is to give this minus 4 and adds to give this 3. So what times is to give minus 4 and adds to give 3, and we just put those numbers in this bracket, 4 and minus 1. So if you do 4 multiplied by minus 1, you get minus 4, as we want, and 4 take away 1, which is 3, like we want. So these must be the numbers, so plus 4 and minus 1. Brilliant, this is looking promising because we have something on the bottom and tops that cancel, and that's kind of, you know, what we're after. And left with 3x minus 1 over x minus 1. Check that this is in the same form as this, where a, b and c are integers, and integer is just a whole number on the number line. So yeah, so if we want we can write this, so a is 3, b is negative 1, and c is negative 1. So that's another way they can do simplify. And so simplify means factorise, and sometimes they make it harder by taking this x squared coefficient not equal to 1. And then you have the more steps. So that's a type 1. So now I'm going to move on to a type 2. Okay, so this is a type 2. So we have two algebraic fractions divided. And first of all, down here we're just going to do a recap. So this is a recap of non-algebraic fractions. So if I have a half divided by, let's say, a fifth, how do I do that? And the steps were, you flip and then you multiply. So that means you flip this last fraction, so it becomes 5 over 1 instead of 1 over 5, and then you multiply. And as we can remember, multiplying fractions is a nice thing to do, you just multiply through, so that's 1 multiplied by 5 goes on top, 2 multiplied by 1 goes on the bottom. So that's a recap of how we divide fractions and how we multiply fractions. So now when we go on to algebraic fractions, you do a very similar thing, you just have to deal with the x's. So the first thing I'm going to do in this case, it looks quite messy, I'm going to factorise again and then deal with the divide. So let's look at this top part and factorise that. So I have 2x minus 2 and I want something in common to both, so I'm going to pull out a 2. In here the 2x, missing an x and a minus. So if I multiply that out, 2 times x is 2x and 2 times minus 1 is minus 2. Okay, so that's that part simplified, that's the top bit. Bottom bit, you can't actually factorise that bit, divided by, and now we've got a quadratic on here, so we need something that multiplies to give 3, this term, with something that adds to give minus 4. So if we looked at the numbers minus 3 and minus 1, if I do minus 3 times minus 1, I get 3, because the two negatives become positive. So yep, if I do minus 3 minus 1, I get minus 4. So yep, these are our numbers. So what we do is we get our brackets with an x in, and we put in these numbers any order, so minus 3, then minus 1. So that's how we do the top one. The bottom part's a bit harder because this coefficient isn't 1, it's now 2. And it's very important to point out with stuff quadratic, factorising quadratics, you can't just divide the whole thing by 2, because a lot of the time these are equal to 0 and you can't divide 0 by 2. Anyway, forget what I've just said if you don't understand. Let's look at factorising this. Let's look at factorising this separately. So we need something that multiplies this time to give 2 times 15, 30, and adds to give 13. I've just written 15. So if we take the numbers 10 and 3, they might take you long to think of, don't worry, just do trial and error, find the numbers. So 10 times 3 is 30, just like what we want, and 10 add 3 is 13, like what we want. So we know our numbers are 10 and 3. So our second line, we'll repeat this, but we change this 13x and we split it up into these two parts. So 10x plus 3x instead of 13x. It's the same thing, but you split it up. The next step, you factorise each half. So what's common in 2x squared and 10x? You can pull out a 2 and an x. Then this one is missing an x, and this term is missing a 5. So if we multiply this out, you can see, quick check, 2x squared multiplied by x gives me 2x multiplied by x gives me 2x squared, and 2x multiplied by 5 gives me 10x. Let's do it over here. I can pull out a 3 because that's common to 3x and 15. That term's missing an x, and that needs to be multiplied by 5. Quick check that these brackets are the same, and then we can do this. So yes, they are the same, so one of them goes in here, and the other one are these coefficients, so 2x plus 3. Okay, so now we can put that, because that's this factorised, here, and then rub it out and do some solving. Okay, so first step, we factorised all our quadratics. Now we want to deal with the division. So just like normal fractions, we're going to flip the last one and then multiply. Okay, so we leave the first one as it is. And then we're going to put multiply instead, and we're going to turn this around. So we're going to put on top 2x plus 3, 5x plus 5, over, and then this one now on the bottom, x minus 3, x take away 1. Okay, and we know that when we multiply fractions, we can just multiply through, so we write all of these brackets next to each other, so we're going to have 2x minus 1, and then we can just write this part, because technically between all these brackets is a multiplication symbol that's just not there, and then on the bottom we can just write these all next to each other. Bearing in mind, we're probably going to want to simplify this because it looks a bit much. So what do we have on the top and on the bottom? X minus 1 top, x minus 1 on bottom. So lovely, we love it when that happens. So we end up with, going to bring that over there. So we have 2 on top, multiplied by 2x plus 3. And then we have x minus 3 on the bottom. So that's how you do multiplying and dividing. So if you multiply still, just multiply through, squish all the brackets together. And the division, don't forget you have the one extra step to flip it. And the first step is, like the simplifying one, factorise. Okay, so this is a type 3, so the adding slash subtracting. So as we can see, we've got adding and then these algebraic fractions, and it says solve this. So if we recap with, so this is a recap with normal numbers, if I did 3 over 2 plus 10 over 3, the method was a cross and a smile. So cross and a smile, and along all those lines you multiply. So we did 3 times 3, which went up here, leave the plus in the middle, 10, multiply along this line, so 10 times 2 is 20, and then on the bottoms you do this multiplied, so 2 multiplied by 3, 6, and 6, and then because you have the same denominator you can now just add the top, so it would be 29 over 6. So cross and a smile was the method we did for normal numbers, so adding and subtracting fractions. So algebraic fractions, exactly the same, do a cross and a smile. So cross and a smile. So you multiply along each line. So let's have a go. So let's just set the scene. So I leave the plus in the middle. Okay, so this line here, so 8 multiplied by x plus 1, it's going to give me 8 bracket x plus 1, because bracket means multiply. 6 multiplied by 3x plus 2, 6 multiplied is bracket 3x minus 2. And then on the bottom you're going to have these multiplied, so 3x minus 2, x plus 1, 3x minus 2, x plus 1. Okay, so your next step, so you can do this different ways, but the sensible thing to do is these are both divided by the same thing. So to get rid of it on this side, I can multiply it on this side. So I'm going to have 8x plus 1, I'm going to have this top line. And then if I multiply every term by this, 3x minus 2, x plus 1, it would cancel with this term. I'd multiply it up here so it would cancel. So on this side I'm going to have 2, and then bringing this up, 3x minus 2, x plus 1. So an easier way to see that might be, because you have the same thing on the bottom, you could have rewrite this as, should have done this in the next step, it would be like that. So this is divided all on this side, so I can multiply it up on this side. Now I'm just going to do a lot of rearranging and expanding. So we've got 8x plus 8 plus 6 times 3x is 18x times minus 12. And here we have, let's deal with the double brackets separately, always a good idea. So let's multiply out this. So this bit here. So for oil. So the first in each bracket is 3 to x times x, which is 2x squared. The outside two are these two, so 3x times 1 is 3x. The inside two are these two, minus 2 times x is minus 2x. And the last are minus 2 multiplied by 1, which is minus 2. Now we can collect like terms, because these are both x's. We're going to have 3x squared, 3x minus 2x, so like 3 apples minus 2 apples gives me 1 apple, but we're on x's, minus 2. So this goes to 2 brackets, and then 3x squared plus x minus 2. So let's keep going with this. So we can collect like terms here, so I have 8x plus 18x, that's 18, 19, 20, 21, 22, 23, 24, 25, 26x. Then we have 8, take away 12, so 8, 9, which is minus 4. And then on this side, we have 2 times this term, so that's 6x squared. 2 times this term plus 2x. 2 times the last term, 2 times minus 2 is minus 4. Okay, so now let's bring it, this looks like a quadratic because we have the x squared term. So let's bring it over to one side and make it equal 0, and then hopefully we can solve. So I'm going to bring these terms over here because I want my x squared to be positive. So I have 6x squared. I'm going to have 2x, and then I'm going to bring the 26 over there. So I'm going to have 2x, take away 26x, which is going to give me minus 24x. Then I'm going to have minus 4 over here, and then if I bring this over here, I'm going to have minus 4. This is going to become plus 4, which is 0. So there we go. Okay, so now let's factorize this and hopefully solve. So what can I pull out? I can pull out a 6 and an x, and we're going to have x here minus 4 here. Because if I expand this out, 6x times x is 6x squared, and 6x times minus 4 is minus 24x. I'm going to write this now up here. So 0 equals 6x, x minus 4. Now for two things to multiply together to equal 0, one of them must be 0. Okay, so either we have this 6x equals 0, and for 6 times something to equal 0, that something must be 0, so x must be 0. Or we have x minus 4 equals 0, so we take the minus 4 over the other side and it comes positive 4. So our answer is x is 0 or x is equal to 4. So the fourth type of algebraic fraction was the ratio question, so I'm just going to write one out now. Okay, so we have given that x plus 9 to 5x minus 1 is equal to x plus 7 to 2x minus 3. Find the possible values of x. So as we've kind of seen by simplifying and stuff, that ratios are a lot like fractions. So the way you do this question is you write x plus 9 divided by 5x minus 1 is equal to, keep the equal sign, and then do the same on this side, x plus 7 divided by 2x minus 3. And now you just solve that equation and find x, and that will give you the possible values for x. So the way you do that is, if it's divide on this side, so it's divided by 5x minus 1 on this side, you can bring it up here and do multiply. And you can do the same thing for the factors. 2x minus 3 divided on this side, so you can bring it up there and do multiply. So let's write that out. So we're going to still have the x plus 9, and then we're going to bring this bit up and multiply, so 2x minus 3. Then on this side you still have the x plus 7 on top, because we all want it on the same level, otherwise it's very hard to solve for x. And then it was divide on this side, so we bring it up and multiply on this side. And these brackets mean there's kind of a means multiply in there. So now you just solve this. We're going to have to expand the bracket using FOIL. So the first in the bracket, x multiplied by 2x is 2x squared. The outer 2 is going to be minus 3 times x minus 3x. The inner 2 is going to be 9 times 2x, which is 18x. And the last is going to be 3 times minus 9, which is minus 27. Let's do the same on this side. So we have the first two, 5x multiplied by x is 5x squared. The outside in each bracket, x times 1 minus 1 is minus x. The two insides is 5 multiplied by 7 is 35, and you've also got the x. And then the last in each bracket, 1 times 7 minus 1 times 7 is minus 7. So now you have to collect all like terms. So first of all, I can see that we have minus x plus 35x on this side. So I'm going to simplify that and put, instead, I'm just going to rub it out, hopefully that doesn't get confusing, and that is going to be plus 34x instead. And then here we've got the same thing, we've got minus 3x plus 18x, so we're just collecting like terms, and that gives me 15x. Could write a new line, but I'm a bit lazy with this whiteboard. So now, again, we've still got a lot of like terms just on different sides of the equal sign, so let's bring everything on this side over this side. So we're going to end up with 0 on this side, and we're going to have 5x squared on this side, and then we're taking the 2x squared over, so it becomes negative 2x squared. We have the 34x on this side, and we bring the 15 over this side, so we get negative 15x instead. We have minus 7 on this side, and we bring the minus 27 over, which gives plus 27. So now if we look at this, we have 5x squared minus 2x squared is going to give me 3x squared. So we're collecting like terms. So 34x minus 15x is going to give me 19x, so that was these two. Now we've just got the numbers, so we've got minus 7 plus 27, which gives me 20. So now we have a quadratic to solve. But the coefficient is not 1 of the x squared term, is not 1, it's 3. So it's a slightly harder one to solve. So the way we do that is, we look for numbers at times to give this a and c. So 3 times 20 is 60. So we want numbers that multiply to give 60, and numbers that add to give 19. And let's see, what are we going to take? I reckon 15 and 4, so if we did 15 and 4, so 15 multiplied by 4 gives me 60, which is what I want, and 15 plus 4 gives me 19, again that is what I want. So we now know our two numbers are 15 and 4, so our next step is, we split this b term up into the numbers we just found, so we're going to have 3x squared, and then this is going to be split into the 15x and the 4x. So instead of writing 19x, you write 15x plus 4x, which is the same thing, plus 20, and that all equals 0. The next step is you factorize each half. So what's common in 3x squared and 15x, and that you can pull out a 3 and an x. So this term is going to need another x, and this one is going to need 5, because if you expand that out, 3x times x is x squared, and 3x times 5 is 15x. Same on this side, what's common, you can take out a factor of 4. then this 4x is missing an x, and this needs to be multiplied by 5. Quick check, are these two brackets the same? Those two brackets are the same, so now we've got the final bit that we want. One of the brackets is just one of these that are the same, and the other is the coefficients. We get 3x from here, and we get plus 4 from here. Now, for two things to multiply together to equal 0, one of them must equal 0. So either this bracket equals 0, so 3x plus 4 equals 0, or this bracket equals 0, x plus 5 equals 0. So now we solve these. So x here, take the plus 5 over, it becomes negative 5. So that's one of the solutions, one of the possible values. And here we have 3x, take the 4 over, it's going to become the inverse negative 4. And then we want to find x, and we've got multiplied by 3 on this side, so we divide by 3 when we take it over the equal sign, so we have minus 4 divided by 3. And there are your possible solutions for x. So that's how you do it, and that's the setup you do if you have a ratio question. So basically, algebraic fractions is a lot of solving quadratics, factorising quadratics, so you need to be really good at that, as well as knowing what to do. And knowing what to do is quite easy because it's exactly the same as fractions, so really the difficulty is factorising and solving quadratics.